Solve each equation and include a check for your solution. So let's start with A. As I distribute across this, I'm going to distribute this multiplication across an addition problem. So this will become 3 times 2x, which would be 6x, and then 3 times 5 is plus 15, and then there's still a minus 3x plus 7. On the other side, let's combine some like terms. I've got a 2x and a negative 4x, which would make 7 minus 2x if I combine those two together. On the other side, let's go and combine our x's also, so that should give us a positive 3x when I combine 6 times x minus 3x and plus 22. On the other side, it's still 7 minus 2x. I guess we can add 2x to each side, so this would give us 5x over here plus 22 equals 7. And then finally, I could go ahead and subtract 22 from both sides. If I take 22 away from 7, I end up with we get negative 15, right? 7 minus 22 is negative 15. And then finally, we'll divide both sides by 5. So when I divide by 5, we get that x is negative 3. Now, that could be right, it could be wrong. Let's go ahead and plug in to the original equation and check. So my original equation says I'm going to multiply 3 times 2 times x. So here's my substituting in of x plus 5. Close those parentheses, minus 3 times x, and then plus the number 7. So you can see in the original equation I had an x here and an x here, and I've put those x's in exactly those places. Everything else is the same on both for that left hand side. Negative 2 times negative 3 is negative 6. Negative 6 plus 5 is 1. So this whole thing right here is just 3 times 1, or 3. And then I've got minus negative 3 times negative 3, which is plus 9. And then plus 7. So I'm looking at 3 plus 9 plus 7. And if I add those together, this is a negative 3, because this is negative 6 plus 5 is negative 1, and negative 1 times 3 is negative 3. So I've got negative 3 plus 9 plus 7, which is 6 plus 7, which is 13. So this whole entire side became 13 when I plugged in x. So if the other side becomes 13, we're good. So let's go ahead and plug our x in there. Again, you can see x is going in 2 spots. So I'll do my substitution for that side. I've got 2 times, here's my x, plus 7 minus 4 times my x. So this is negative 6 plus 7, and then this would be plus 12. Negative 6 and 7 together is a 1, and 1 plus 12 is indeed 13. So absolutely, when x is negative 3, it makes both the left hand right hand side both the same. It makes them both 13. So x equals negative 3 is my solution, and it's my checked solution. It worked. Let's move our attention over to B. The thing that I immediately am drawn to are these fractions and the fraction buster technique. So what I'm going to do is multiply both sides of this equation by 4, and it'll clean up all the fractions that I see. It'll take care of this, and it'll also take care of this fraction. So let me go ahead and do that methodically. So this is going to become 1/4 times x times a 4 plus 5 times a 4 plus 3/2 times 4 plus I think I had the problem off the screen, plus 2x times a 4, and then minus 14 times 4. So let's simplify that. That's awful looking. Well, first of all, 1/4 times 4 is 1, so this becomes just plain old x, and then this becomes a plus 20, On the other side, this is my equals, of course, big mistake. That's 12 over 2, which is equal to 6, so this equals 6, and then plus it would be an 8x, and then 4 times 14 I believe is negative 56. So if I combine the negative 56 with the 6 on the right hand side, this becomes an 8x minus 50. On the other side I've got x plus 20. I can take away an x from each side. 20 equals 7x minus 50. And I can also, let's see, add 50 to each side, so that becomes 70 equals 7x. So if I divide both sides by 7, then I'm getting that my x must be 10. Now, probably pretty important to go through and check that to make sure that it's a correct solution. So let's go ahead and do this. I'll just write it up above here. Here's my check. So I'm going to have 10 fourths plus the number 5. And on the other side, I'm trying to see if that's equal to 3 halves plus 20 minus 14. So if I combine 10 fourths plus 5, I believe well, let's see. Let's do this. 10 fourths plus, if I want that to be fourths, it would be 20 fourths. So I end up getting 30 fourths on this side, which is 7.5. And on the other side, I've got 20 minus 14, which is 6. So this is 3 halves plus 6. Well, 3 halves is 1.5. And when I combine 1.5 and 6, I do get 7.5. So when x is equal to 10, it made both this left hand side and this right hand side were both equal to 7.5. So this is definitely the solution. So x must be 10.